So here come our very last lecture. Next week will be yourself, right? Not me. When we are done, after this class, of course, we can do some Q&A and then we have exam, right? So that would be a thing we'll talk about next class. Okay. So let's finish this set of slides. It will not be too long, but you'll have to be very careful. So from when you do dynamics games of incomplete information, and you have to be super careful because there are many things to track, and things are not that immediate. Okay, but let us review what we have done. Okay, so last class we worked on the most complicated type of game, dynamic games of incomplete information, which we will focus on the most common equilibrium concept we call perfect Bayesian equilibrium. Okay, and in fact, this is not the earliest one being proposed. The earlier one is actually they call the sequential equilibrium, which if you define it, actually it's more technical. Okay, it involves you consider a sequence of strategy and talk about the limiting case. Okay, so you start with complete mixed strategy and talk about the limiting case, and that is way more technical than we need. And turn out in most of the game we're interested in is actually there's no difference between two equilibrium concepts. So that's why in the literature we focus on perfect Bayesian, right? Unless you're talking about a lot of complicated games, but otherwise in a simple finite game, then you have no difference. Okay. So the way to proceed is to combine the Bayesian idea with extensive form game. And clearly that is different from previous one because belief is not static. Okay. And what you think about the other players type can depend on what you have done. Okay. And people know you have information advantage or disadvantage may exploit it, or you may misrepresent that, right? That's you see the pooling equilibrium, right? And so that turned out to be because belief is very important to design your strategy. So that's why it is recognized by economists that belief is actually part of the equilibrium. Okay, it is as important as strategy. Okay, which is not the case when you talk about previous three types of game, right? Where belief are given, right? And here the belief is actually evolving. Okay, and the problem is what is reasonable belief is the most difficult part of characterizing equilibrium or how to define equilibrium. And the way we do is we learn that the belief is important because if you don't explicitly write a belief, then you allow something strictly dominated thing to be there, which is okay when you talk about subgame perfection, right? But when you actually talk about information, and there is some issue here. So we define perfect Bayesian equilibrium to be a pair of strategy and belief, right? Belief is important, right? And that has satisfied three requirements. The first requirement is more or less trivial, saying that for every information set, there will be a probability system, right? So everything must add up to one. You must belong to somewhere, even though in equilibrium is not there. So every information set, right? So the key. Oh, have I shared the screen? Probably not. Sorry. So the key here is the perfect Bayesian equilibrium. I have to satisfy for every information set. right? That actually means that you have to put belief even though in equilibrium, those nodes are not there, right? So that is exactly what you see in the example. R prime, equilibrium actually doesn't tell you whether you're L or M, right? But in that case, you still have to put a belief over there. So that is a very important part. So although it's simple, when you know it, but it's not trivial. The second one is more or less trivial, is that trivial in terms of understanding, right? Because given your belief that you are optimizing at every information set, right? So it's just nothing but what we know, right? Just there's no other strategy that can do better. So this is trivial. Of course, you see the perfect, so it means that sequential rationality. So in each subgame, okay, you have to be that, right? But subgame cannot cut through the information set. So each subgame you have this idea. The last one would be the belief would have to be rational. By rational, probably you would learn from your first class in probability, right? We say the learning, how update your beliefs will be follow the Bayesian way. That is the way. But of course, those of you who learn machine learning or they will learn there's some non-Bayesian learning, right? But we'll focus on the Bayesian. If you focus on non-Bayesian, then it's okay. There's another type of learning, right? But if your player are fully rational, they should learn according to a Bayesian, right? And of course, what does that mean? There's a strong restriction. It means that actually you're thinking about the game is played repeatedly, right? Even though you only pay once, but in your head, you just run this many times, so they update your belief accordingly. So you think ahead, you simulate in your head, okay, many times. Then that is how you form your belief. Okay. But that is that's the idea. Okay, you simulate that in your head. Okay. So this is example we have seen already, right? So this is a LM. You have to assign probability. This is a requirement one. Okay. And sequential rationality implies that for this belief P and 1 minus P, you have to choose the right thing. And you can see this doesn't satisfy sequential rationality once you put the belief, right? Although the belief is free, you can choose because it's not on the equilibrium under R prime, because it's R here, LM is not chosen. So P and 1 minus P can be free. So requirement 3 doesn't impose anything. And this is imposed by requirement 1, you have to put belief. And requirement 2 will tell you that you never choose R prime because R prime is strictly dominated by L prime. So L prime will be chosen in any cases. So that's why it's the case. Okay, just to remind you that there's a typo here. There's a PB, not PNE, but I guess it's not something you would worry you. So let's go to a signaling game. And you may be surprised at why we suddenly focus on some simple game. Okay. The problem, as I tell you, that even this game is complicated to solve. Okay. And you will see many different games, and then we are just focusing on a very simple one. Okay. And those of you actually attend this week our department seminar, more or less is this actually he's doing this kind of game, signaling game. But you have multi-stage thing. So that's a chip talk in the first round, and the second round is causal signal. So you have two types of stuff, but the idea is very similar. So even frontier research, when to apply just a variation of this kind of game within the class. So because it can be very complicated already. So here we have sender receiver game, and the sender can send different message, and the receiver can take action after seeing the message. So the M is the message space, and A will be the action set, and T will be the type, okay? And P actually should be small p should be the belief, and then US and UR as well, okay? That's a payoff function. And the game is just like the nature draw the type of sender, and sender decide the message to send, and receiver receive the message and take action and the payoff, okay? And particular point you will see is the stage 3 is where the belief will perform, right? So initially, the receiver with the beliefs according to base rule would be following the nature, right? But once nature do something and the sender do something, and the receiver will update it, okay, according to the Bayesian way, if in equilibrium, and any type is possible, then if there's not equilibrium. This is a game tree. This is the way I draw it, and also the book draw it. But of course, I can draw it from the top to bottom. But this is actually more convenient to write, because if you actually ever try to draw it in the up and down, then you will have the nature will choose type 1 and type 2. And there will message 1, message 2 here. Same for this one. But the information set looks like this, right? So it looks, it's okay, but looks a little bit uglier. So if you draw top to down, we like this. So that's why you see the papers, they would draw in this way. So this is, you see in the paper that in the 80s and 90s, they talk about, they draw in this way. But it's okay to draw top to bottom. It's okay. Which is usually we draw, right? The trees of the bottom. So nature would base on the common belief that you go up and down, right? And once the go and down, the sender know whether he's here or here, okay? And the sender decide whether message, what kind of message will be sent, and receiver only see the message but don't know the type. So he will form a belief over that, okay? It will be Bayesian style, okay? And according to equilibrium. But anyway, after that, then you just apply what kind of A1 and A2 that you see. Okay? Let's repeat the analysis. Okay. The first, we form a system belief up to 1. And this is you are maximizing everyone. The sender is sending the right thing. The receiver also sending the right thing and doing the right stuff, right? And then the belief actually will be, if there's more one type being sent, then the beliefs will be updated accordingly. But if no message is being sent in equilibrium for some type, then the belief on that message can be anything arbitrary. Okay. But of course, you may want to strengthen this one. It's up to you, but the basic one don't have this strengthening idea. Okay. So here we illustrate, this is the 3 types of model that you analyze, but the last one we will skip, but you can also always check the textbook. Okay, the first one is separating equilibrium, which means different types send a different message. Pooling means everyone send the same, but it's also hybrid. It's also that one type always send one, and some message sent by one type, but some message may be sent by both types. Okay, suppose there are 3 types, right? So type 1 may be sending one message. Type 2 and type 3 sending mixed message. Okay, or there's 2 types. Type 1 is taking 1. Type 2 is randomizing over 2 types. Okay, but in our class we focus on pure strategy. So when you have 2 types, then you don't have either the same or the different, right? So there's no pure strategy. You can you do things like that. Yeah, you can't, right? Either the same or the different, right? You only 2 types. You 3 types you can more, or big strategy. Okay. So this is an example. I want to go through that again because it's good to see how we derive that. Okay. So let's focus on the case where we talking about I think pooling equilibrium or separating equilibrium. So let's see again how we derive this. Probably you know very well, but I want to do it again to make sure everyone's on the same page. So let's check all possible strategy by the sender. That is easiest, okay? Because from a top-down approach, you focus on what kind of sender can send. So that is called separate the proposed equilibrium and separating one. Okay, and if this is the case, then this will be 1 according to the Bayes rule. Okay. This is the criteria of the PBE of the last criteria, right? If the belief is not arbitrary, okay? Why this case? Because if you run this in your head, right? Every time type 1 is only send L, type 2 send R, then you must have this belief, right? When you see when you see left message must be type 1. When it's the right message must be type 2, right? So that would be something required. And here we will impose check the criteria 2 for the receiver, which he has to add optimally under the belief. Okay, if he believes this is 1, then he's only compare 3 or 0. Basically, this is chosen. Okay. And same here, he believes he's here. It doesn't really matter which one. Okay, so it can go either way. Okay, and that means that we have to check 2 scenarios, right? Check. Suppose this is the case and the other case, right? So that two cases here. Okay, the first 2 subcases, this one. Okay, and you can see we actually check 3 criteria, right? First is this system of belief? Yes, we're done. Is it belief derived from Bayes rule, the last criteria? That's okay. The second criteria have 2 things. One is sender optimality, the other receiver optimality. Okay, receiver optimality is there. So what's left is only one thing: check the sender optimality. Then you're done, right? Because you only need to check 4 types of stuff, right? System of belief derived from Bayes rule, sender optimality, receiver optimality, right? So the only left is sender optimality. Sender is looking at this, right? Because he doesn't know. So that's if U is here, this is also U, right? And if U is chosen, it's the case, right? So let's see if the sender 1 would be optimally sending L. The answer is not, because if sender instead of L is an R, he'll get 2, right? Which was 1 here. Okay, so choosing U in here is not. So this subcases is gone. So this can't be U. So, but remember, we still have another case is D is being chosen. Okay, then we'll check sender 1. Is it going to be good thing? Sender 1 is going to send L1. If he deviate to R, he actually be thought as sender 2. He got D treatment, which is 0, which is okay for sender 1. Not for sender 2. In equilibrium, he's sending R, he will get D treatment, which is 1. And instead, he pretend to be sender 1 by sending L, he actually get 2. Okay. So in that case, that actually this is not a equilibrium, because sender would not find it reasonable to actually separate it from type 1. So he will pretend L as well. So in this case, there's no such an equilibrium where type 1 send L, type 2 send R. Okay, that's done. Is that clear? So we do it step by step. So that is now here is we're done with, there's no separating equilibrium in this one. So there's another separating equilibrium, which is type 1 send R and type 2 send L. Okay, so let's erase this one. Suppose type 1 send R, type 2 send L. Okay, and we'll check this optimality at the end, as we do. So once the first thing to do is to make the Bayes rule works. So this is 1, this is 0, right? And this is 0, this is 1, right? So this is coming just from the Bayes rule. So first you pick the strategy of sender, and then you led you to the Bayes rule. Okay, And once the base rule, then you will tell the receiver what to do, because receiver thing is here. Okay. So between 4 and 1, of course, he will choose U. Okay. And because he didn't know, though, this is also U as well, because he didn't know where he is, but only he can choose U. Now for the receiver here, he thinks he's here. His choice is U give 1 and D give 0. So of course, U will be chosen as a result. Okay. So we have now with system of belief based on base rule, we have receive optimality. What left is the sender optimality here. Right? Check the sender 1. Sender 1 in EPM, he get 2. Okay. And if you deviate, he will get 1 only. Right? If deviate to pretend to be the low type, you actually get 1. Okay. So this is okay for sender 1 again. How about sender 2? Sender 2, he set L in equilibrium. You get 2. But instead he deviate, he'll get 1. So that's okay as well. So we check all 4 conditions. So this is a separating equilibrium. Okay. Again, let me repeat that 4 ways to check. 4 criteria. First, you have system of belief, criteria 1. Okay. Criteria 3 will be saying that your belief derived from base rule. So we get 1, 0, 0, 1. And the second criteria have 2 parts. Part A is receiver optimality and sender optimality. Okay. Receiver optimality will be just looking at what we have seen. And after that, you will do the sender optimality. Okay. So that's how you solve this kind of game. It's not something very complicated, but that's how we do it. Okay. Is there any question? If no, then we go to a more complicated one, which is the pooling equilibrium. Because pooling equilibrium, there's some message is not sent by certain type of sender. It means that the belief there can be more free. So you're more to check, right? But here it's like the belief is fixed, so everything is very simple. So let's look at the case of the sender send both types send L. Okay. Being both types send L, which means that L tell you nothing, right? If you see the both type. So which means that the receiver, the belief should be 0.5 here, 0.5 here. All right, because both type the same message, then you can't improve what you think. Right? Half of them must be, is still half the case, you will see L, half the L should be from type 1, half of L should also from type 2. Okay. And this Q has nothing to say. Okay. Because it's not on the equilibrium path. The only thing restriction is written is Q 1 minus Q. So you just, this is the from criteria 1, right? Must be system of belief. As long as they add to 1, you're done. Okay. So we're done with the first criteria and the last criteria. Okay. The only thing left is based on this system of belief, what kind of strategy that is feasible. Okay. Look at receiver. Receiver is thinking half of time is up. So half the time he's facing type 1 and half of the time facing type 2. So if he ever choose U, his payoff is average, assuming risk neutral, is half of 3 and half of 4. Okay. So the expected value or expected utility is 3.5 because it's risk neutral. Okay. Of course, we can assume risk averse, but that is another case. Assume risk neutral. And the other case, D will give him 0 or 1. Okay. And expected value is 0.5. So there's no way that he would choose D. That's U is the only thing you can see. Okay. So what about the receiver when you have here? Okay. The receiver you here. So he has belief like this. Okay. And this belief we said is arbitrary. Okay. And it's clear that you have 1 here, 0 here. Right. So average will be just Q. right? 1 times Q times 0 minus 0 times minus Q, right? Up is Q. What you get on expectation will get dot. Down will be 2 times minus Q, right? It's 2 times minus Q. So with DOTE math, you will see if Q is large, you choose U. If Q is small, then you will choose down, right? And the threshold will be just calculated by this one, the equal, right? Or you make it above is fine, right? So what's the probability that you would choose up over down, right? You can solve out this is Q is large enough, right? Q is larger than if Q larger than 2/3, then U will be chosen. Otherwise, D will be chosen as well. So, but the belief is arbitrary, so we can do anything. That's okay, right? So we give a lot of freedom on this one. So let's focus on the case that he believed is the case, right? He believed is the case. A lot of time is Q rather than Q is higher than 2/3, right? So U is being chosen. So you can do the other way around, but focus on the case first, subcase first, U will chosen. So now everything is fine. Only thing left is the send automatically, right? The receive automatically is done. Then the send automatically look at sender 1. If he choose L in equilibrium, he get 1, right? That's what he's getting. Okay. And if he deviate, actually, no. If he pretend to be sending R, he will get the treatment of 2, right? Which is better, right? So he would not actually go with L, then actually send R, and he would be thought 2/3 of time, at least 2/3 of time is type 1, and then he will get a favor treatment U. So that's why it's not equilibrium. Okay. So this subcase is gone. So we focus on the case where Q is less than 2/3. Okay. In that case, it's not U, but actually D is being chosen. Okay. So okay. So under this subcase, type 1 sender getting 1 again. But if he send R instead, okay, he would be treated as D, which is 0. Compare 1 and 0, then this is okay. Now what remains is sender 2. Sender 2 in equilibrium, he is getting U here, he will get 2. Okay. And if he deviate to be R, and he will be treated by 1. Okay, 2 is better than 1, so this is okay. So this is a pooling equilibrium where both sender will send L, okay, and under this, the receiver, the belief will be just P will be half and half, okay, and Q is not from the base rule, but as long as Q is less than or equal to 2/3, that's okay. Okay, this will justify why D is being chosen. Okay? And because D is being chosen this way, then can support U here. Okay, so is that clear? So actually now we have at least 2 equilibrium, 1 pooling, 1 separating. Right? Is that clear? Is that okay? Now, what is left is the other case is both senders and R, which is we haven't covered last time. So we just stop there. Okay. So let's see this one, how we derive it. Okay. So here we will derive it based on same idea because the receiver actually learned nothing from the sender message because the both senders send the same message. So your belief will be same using the base rule, right? Because half of time is 1, half of time is 2 type 2 message. So you still remain 1/2 here. And this P, how you assign that? Anything you want, okay? But clearly, it's not free because you have 3 and 4. D, you have 0 and 1. There's no belief that no matter what you assign, it's going to justify you would choose D, right? Because U, no matter P you assign, okay? U is strictly dominant, right? Because U is better, right? No matter. But anyway, P can be anything at the moment, okay? But we'll say because P can be anything, but no matter what you do, 3P plus 1, 4 times 1 minus P must be bigger than P times D, P times 0 plus 1 minus P times 1, right? So no matter what P you are, this must be the case, right? No matter what P you are doing in your mind, right? Because 3 and 4 must be bigger than 0 and 1. There's no P that you would justify other way around, okay? What about this? Receiver is having belief 1/2 is here, 1/2 is here, okay? So 1/2 is here, you get, again, 1 and 0, average is 0.5. 0 and 1, 0 and 2, average is 1, okay? So the only reasonable thing is only D, right? So the only thing that is possible is D, okay? Because U is only have 0.5 payoff, D is payoff of 1. Okay. So let's check. What remains is set a sender. Is the sender happy here? The sender is setting the payoff of 0 according to equilibrium, right? And if we deviate, we get 1. Okay, so there's no way that we're done. Okay, so we have checked all possible equilibrium. Okay? So there's no difference from that. Okay. So now we know 4 possible candidates, only 2 survive. Okay, there are 1 separating and 1 pulling. Okay. Of course, this graph already drawn here, so you can check my slides. Okay, how I do this, right? If you want U, it will be more than 2/3, right? If you want D, with this one, right? So there's no pulling on R. Yeah, there's pulling on L, right? There's no pulling on R. Okay. Oh, sorry. Did I make it wrong? Oh yeah, that's right. I'm right. Yeah. There's no pulling in this case. So that's done. Okay. So here we end our toy model. Okay. Is there any question before we continue with our baseline model? If done, we are going to talk about this game, which later you will see your head will burn out, okay? Because it will be very complicated. I'll go very slowly because if you know this game how to solve, then you know almost all the game. So this is once you understand this part will be, the rest will be very easy. Because when you look at the proof, the real proof of this paper, that can be very complicated. Okay, but the idea is very simple. To write down formula is very complicated, but the idea is very easy, but can be very convoluted. So prepare your head to be very convoluted. Okay? Already, I think it's very convoluted for me. Hopefully, when I teach, it's clear. Okay, but I'm not have full confidence I can teach very clearly. But so the game is actually very famous. I think this earned him the Nobel Prize. It's a span signaling game. Okay, the game is actually this game is one of the why it's so famous. Is also at that time in the labor economics, people worry about or think about what is the use of education, right? Is education going to improve your productivity, or education is simply signal, right? Because education basically, well, you teach people calculus, and how many people actually use calculus in their life, right? You teach other people a lot of history, you teach people a lot of art and literature, which is most people who don't find useful in their life. Maybe useful in life, a lot of for the work, but why we still school or why the job market still require you to do this, right? Or in the other word, right, in econ, but that not in the other discipline, right? Because at least you would require to take, at least in finance, right? Also, you require to take the quantitative exam, qualifying exam in micro and econometrics, right? Or some people would have to, in economics, everyone have to take micro and macro and statistics, right? But most of us actually would not use one of them, right? And most use one of them, right? You only do micro or you do macro or you do metrics. Where few people would do three of them. So the question would be why is it useful, right? Because we're economists, right? Tend to be very efficient. Why we're wasting student time to do something they don't need, right? The reason is if you're able to do those, actually showing you to pick the smart student, right? Most likely to successful in their research, right? Is able to pick up something that they don't know or they don't, not easy to learn. So that's one reason why signaling game is here, right? So that's why you're asked to take this class. Of course, one of the reasons is there's some usefulness for this class, but of course, not everything is useful to this class, right? But by doing well in this class or also other coursework, right, is trying to show you're able to solve some difficult problem, okay, have some quantitative skills, then your future advisor can able to pick, right? Of course, in here, I don't think you have advisor already, but many places, your advisor is not fixed until after the first year, right? So it's how well you're doing in the introductory classes, allow the advisor to know you more, right? If you're not good enough in the coursework, then probably you will not be, you can't find a supervisor, then you quit the program. That's happening in many US top PhD programs. You're not good at the coursework, then they just kick you out. Okay. So that is the signaling game idea. Okay. So here, just let me continue. So the game is like this. So nature decides how productive you are. So that is a private information. Okay. And everybody knows that the probability Q is you have a high quality. So how you get the Q can be just proportion of people who is doing good. Okay, so that is a common knowledge here. The second one is signaling game, means that you have the type, and your type would decide how much education you're getting, which is a message. And this message is costly. Okay, if the message is costless, okay, that will become a cheap top literature. Okay, that would be different from what we're doing. So it's not signaling game, but rather it become a coordination game. Okay, but here we focus on signaling game. So which means that education is not free. So when you send a message, it's costly. Okay, and the cost of education depends on how much education you got, which is E, and also depend on type. And obviously, if you get more education, it's more costly. The furthermore, it's more costly as well. It's convex cost, right? I think the effort you spend on primary school is way less than your first year here, right? So it's a convex cost. Okay? And here we have what we call the very famous condition for single crossing, which means that if you high ability, the marginal cost of education is lower when you high type. Okay, so this single crossing is important because without this, then basically you will end up with all the useless equilibrium, right? Because if low type can send signal cheaper, then there's no need to do anything, right? But of course, in this model, you only two type. This is this assumption is innocuous, right? Because I didn't say anything high or low, right? It's basically useless, okay? Up until here, okay? And here is to get the idea, the type meaningful, you have to say how is the value of to the firm. And here is in order to make the model easier, okay? You assume that actually two firms are making offer to the worker. It's a per-child competition. So that means that the worker get out of surplus from the education, okay? In that case, the worker are given their output directly. Otherwise, you have to think about how firm compete and all this kind of thing, right? Of course, subsequent model take into account of this, but we assume that the worker is getting all his output, okay, his marginal productivity, depends of course on his ability and education. So here, the 74 paper actually allow this your productivity increase in education, and the 73 paper actually don't allow this happen. It's pure signaling game, okay, and that means it's more general, right? Because with education actually improve your productivity somehow, right? So here we also have another single crossing productivity idea is increment for the high type is more than low type, right? So there actually the education is actually good for the worker, right? And also it's not that costly for the worker as well, right? Otherwise, the model will be a little bit convoluted to solve, okay? But I think most of the time this thing fit very well. So high type is actually good to get education. It's cheaper to education, also good, better for the firm. Okay. If this is not the case, then the model will be more complicated. Okay. But you will see it's not very difficult to solve if you don't follow this. Actually, this make the model more interesting. If you relax them, the model will become less interesting. Okay. So that's why they solve this game. But you can actually see at your home, you can try to relax them. It's not something too terrible. Okay. And here, as we said, because of the two firms competing the worker, right? So the worker get his wage minus the cost of education, and the firm get his output minus the wage, okay? And it's set because of per-child competition. So this wage will be equal to the output, okay? So that is what we said because of perfect competition. So, and because both firms would hold the same belief, okay? That means that the wage is just expected productivity, okay? So how much a firm is going to offer will be just expected value, okay? If you're from finance, it's a very standard model, right? You know what is the price of a stock will be the expected value subject to the signal you see, okay? This is very common, commonly observed when you look at model in asset pricing, okay? But, okay. So because of two firms are competing, so basically you can consider this one firm, right? And the firm is just making the offer, right? That wage is not doing anything, right? So it's just basically making the wage offer directly. An offer they get is just follow this simple approach. Okay, so the model is pretty simple, right? Because the firm is just like the action to take it just like this, right? Because this is the wage he's doing. Okay, he just basically form a belief. Okay, so after the break, we'll talk about the benchmark case. Okay, and why we talk about this? Because benchmark case will allow us to differentiate several subcases of the analysis. Okay? So that means that you will see the model is becoming more complicated. Okay. But for the moment, I guess we should have you reply so you can tell me how you're doing. Okay. And also, this is our very last class. We are celebrating as well. So just some snacks in case we are going to do it. But let's a break of 15 minutes. So we'll resume whatever 15 minutes after would be 10:30. Go around to celebrate the end of our semester. If we take some candy bag, snack bag. Celebration end of our course. Congratulations, last class, no more class. No more class. Next class is our open book exam. Here you can have yourself. We do other run after the next break. On this next process, you come to do the exam. No more lecture. Yeah, maybe you're the great question. More class. More suffering from economics. End of the suffering. Basically, it's small, big, both are big and small. Those kind of small. Where they able to feel basically only Chicago. Yeah. Job help. Yeah, I don't they only do but doing construction of farming and most of you see most many of the doing theories basically come from economics. I don't know. No, I don't think it's more difficult. I don't think it's because that's job market because that's probably some every school in here. Oh, right. Everyone came up, everyone know progression, so what's the problem? Right. But I see that's a very important thing. So it should be a good question. We are having something different. Yes. First principle to counter advantage. Do something that has advantage on. And the accounting, do the accounting thing is good question. Data available is much more than other design. So everyone and so many questions. Yes, we do it a lot of stuff. But of course, parallel trends also what they do. Taking the S. Otherwise, that's still have a very high standard of cost of analysis system. So we can do it again. I think we'll start with the same two. Yeah. Yeah, data you can get is limited. Everyone want to say the data from what people run off data. If you look at any book, then I find it probably has. But yeah, I do know that here's my life. By the way, where this is your speech. Yeah, because well, yes, everyone doing this for something like this. Get go some structural or at least the structure you can do the structural policy. At the end of the day, maybe something, right? Because without feeding it, and with all your why you predict this not the other way around, and you just don't know what it has to do. Yeah. Because you can run everything can be done, and then can explain everything. That's like all. So form hypothesis. Well, that's a form hypothesis, and then the question is model more as limit internal consistency hypothesis. Or otherwise, you can say whatever you want to say. Say that's fine. Marketing. You call people for more restrictive. Right? Is who can rule to that effort. That is fine. Yeah. But the same for all something challenging. Yeah. Otherwise, I very 新的是高的，然后主要是高的，这个讲是高的，一部点应该是40块钱一天，便宜一点，把它给对，然后中午那上来了，我有上了，来到来看看，再看其他的对，老板怎么看来着？比较比如 Y 是吧？Y 是吧？这个差哦没有，好看，Y 是吗？Y 是好看，接下来是 N 是后来炒对的没有？这是要把这个放一个，这个地方的话就是没有然后不炒对。发一什么发展大的商品，有个人说对，一般来说不好的，后不说好的，这个巧克力的味道在里头，我感觉好，我会啊，别说上次差别啊，因为不过这边不过去这个对面吧，为了所有的过程很少，来，不行，对，因为在哪里？在基础数学嘛，我那个同学，把那个真刚才就错了。现在我2个买的话，肯定是小那个小问题。为什么有一个茅台咖啡？香港茅台咖啡，有吗？香港有，茅台也可以有买得到。这个香港啊，啊也没有了，哦，这个茅台咖啡也没有了。我会第二买，哦，这个买的话可以买到，这个可以买的话，就是没有那个一个累积。在茅台咖啡不是，就是它有跟那个 Irish coffee 这样，爱尔兰咖啡调，挺好的。Irish，我在买一个便宜的 Irish，然后呢，这个以前我就是很多时候买，回来到在你要远开车，冬天喝特别好。哇，So let us resume, I guess. See what happened. Happy last class. Would there be a sample final? Did I put it there? Have I? Oh, I didn't. Quite surprising. I thought I put it there, but let me quickly put one. I use last year one. I used last year, the last year, 2 years ago. But so this is my something like that. Okay, so with this question, let me upload it. This is difficult is everything more similar. Yeah, this is not last year, it's the one that I put a few years back, but so I can go for a little fairly quickly to let you know what's going on there. So last year, I'll say before last year, so 2 years ago. So what I do is I have 5 questions, but I think this year I only have 4 questions. Okay. And question 1 is about consumer. I give you the utility and then compute everything. Okay, compute your MRS, solve the utility maximization problem, do the Maxwellian demand in direct utility, do the management problem, solve the Higgs demand expenditure. Right. So there's something I think I asked already in the problem set. Okay. And problem 2 the same, but if this is a CES, then you do the same. I asked you to do the cost minimization, input demand, total cost, profit maximization, input, and this is a way standard, right? So this is asking producer and consumer the same. Okay. And I have here uncertainty. Okay. So I've tried to ask you, give utility function, calculate the risk aversion. If you're given 2 log 3, okay, calculate the risk premium and compare these 2 log 3, which one you would prefer. Okay. And question number 4 will be on the game. Ask you to farm pure strategy, mixed strategy, and farm in subgame perfect when this repeated 2 times. Okay. And if you repeat many, many times, what would be the discount factor to support the outcome for say, right? Okay. And the very last one will be the price competition between 2 firms. Okay, they engage some kind of price competition, then what's the Nash? What is subgame perfect? So that's stack over. And here we have the Bayesian equilibrium. Okay. So that would be the idea. So currently I set the final exam will be 4 questions. And you would have first 2 questions is about the first half of the semester. Second 2 questions about the second half of the semester. And because I think I make the question slightly more difficult, but that means that I only choose 2 questions out of 1 in the first half, 2 questions out of 1 in the second. So that would be basically you just answer 1 question for the first half of the semester and 1 question for the second half. Is that clear what I'm saying? So the 4 questions, 2 questions, just 1, but it will be for the first half of the semester. So first 4 chapters, there will be 2 questions and you will answer 1. And there will be 4 questions, the 2 questions on the second half of the semester in theory. And you will choose one of them to answer. The question is slightly more, slightly more, slightly more difficult. You have to think carefully how to do it, but otherwise the same thing. But that would be something. So it will not be something complicated because you have like half an hour to do one question. The problem is only probably without the thing. Because you take one question from the first two and one question from the second, last two questions. I think easier from the last year. The last year, I have 4 questions only 1 hour. Now I have 1 hour, 2 questions. Of course, you don't need to do 4 questions. Only do 2 of them. I will grade the first 2 questions you answer. If you answer 4 questions, it doesn't help you anything. Just grade the first 2 questions you answer. Okay. Okay. So then we can go. So something along the line you have seen already. Okay. So similar to your assignment and also this past year papers. That'll be, I mean, the thing I asked is already an assignment also makes sense, always straightforward. Also, the thing that actually you need to know. Okay. I'm not interested in asking some with special assumption, how to change this. So that's basically think about how to derive the thing. And I asked the TA to do it. The TA said it's okay. We can stop. And you can absolutely no problem do it to now. If you bring your material. So yeah. So maybe some calculus require like, right, question 1 and 2 in this past paper, right? Some calculus, doing some Lagrangian, right? And then after that, you just game theory, right? With some inequality handling here, right? And do this last problem with just some calculus, and that's it, right? Something with the math use. We are not asking you to do anything. That's no group. Just some calculation. Very good question. Thanks for telling me that I haven't uploaded, because I always think I upload it. Because most of the time I upload it at the beginning of the semester. So I don't know why this year I didn't do it, but good to let me know. 8 or 9. 8 is also game theory. So today's material is also can be included. Okay. But one important thing I can say, I don't think I ever asked in the exam since I taught this class here. So you might have it or you might have it. But I have the one thing I can tell you, I never included in the exam before. So I don't know, it's more likely or less likely. I can't say, but that's why the fact is I can say is like I have never done it, but it might or might not, but cannot tell too much about that. There are no 9, only 8. Okay, up to the game theory, the 4 class. Up to today's material everything. But that's why we celebrate. That's the end. Page 27. It's a question on the slide. Oh, thank you. I said H here. Yeah, because your probability education height and high is no 1 minus. Sorry about it. But they must add to 1, so that's okay. Thanks for telling me this obvious typo, which I shouldn't have done it, but it appeared nevertheless. So today is that's good. There's no question. Over is okay. You can follow. Oh, this is the first time I saw this triangular or shape. We don't have any way tie, but very happy that we are not okay. Any joke to share? No, that's okay. So now we are done with this. We go back to this one. Okay, so just remind you, this is a typo here. So here comes from the baseline first is you can assume the baseline case. Very often when we talk about incomplete information, when we look at the model, we always solve the problem of complete information as a benchmark. Okay, if we benchmark, and it will be a nice result as well. So in this particular model, and we will see firm can see the ability directly at education, okay? And the worker actually get the actual productivity, right? Because the ability can be observed with high or low, right? Because ability eta must be high or low, right? So they get what actually they do. So what they do, there's no information asymmetry. That means that they will just choose the education to maximize their net benefit, which is the wage minus their cost. Okay. And of course, it depends on the type, what you get, but we denote this as star. Okay. This is optimal one, the star. Okay. It's optimal education will be like this. Okay. So in the two type case, it will be this graph. Okay. So we make everything linear to make our life easier. So this is the high type productivity, this low type productivity. Okay. You see the way I draw is the YH is much steeper than YL. That is because of the assumption, right? And the assumption, well, more steep is this assumption here, right? This assumption. Okay. It's upward sloping because of this. Okay. So these actually give you the two lines. Okay. So this gives you why you have upward sloping. Second, why this is more steeper than the other one. Now, second would be why you have this indifference curve. Okay. And why I draw in the way that when they cut, it will be in this. Okay. It's come from the idea what we call single crossing. Okay. It's the cost of having education is lower for the high type. Okay. Let's look at the indifference curve first. So suppose your type L, the indifference curve this way. That means that if you go in this direction, this is better, right? Because you get higher wages, right? Look at, so compare this point, you go up, right? So going up is actually better, right? And why your indifference like this? Right? You want higher salary, right? But getting education is more costly, okay? And more costly more. So you will upward sloping, right? It's not a flat line, but it's upward sloping, right? Because money and this is related non-linearly, right? Because this, when you are here and here, right? Okay, you have a lot of education, okay, to compensate your same indifference, right? So you get some education, then you just only need to get this little bit rise to make you indifferent. But when you're here, you have a lot of education already. Ask you to take one more year, then you are not very happy. So you need a lot of money. So that's why it's in this shape. Is that clear why it's this shape? This is due to the idea of the convex cost of education, right? Because to compensate the other year, okay, when you have no education, okay, when the primary school asks you to take one more year, I only need to compensate little salary. That's okay. But when you're highly educated, I ask you to spend one more year in school, then you're not very happy because it's very costly to do so. So this to cut like this, let's go up. Okay. So that is the first why is convex. But the problem is why you have this guy here. Okay. Actually, this is the idea of single crossing, right? Because of the slope represents the MRS, right? So it is flatter when you are having high ability, right? So that means that when they cross, they only single crossing means that they only cross once, right? For any indifference curve, pick two indifference curve. You can only cross once. Okay, it can't be this and go again, right? So that means a single crossing. So you can't cross again. You can't. Okay? Once you cross, it's over. Any difference curve, any two difference curve of two types, they only cross once. That's the meaning of single cross. Why? Because when they cross, right, it must be the case that high type is more faster, right? And then it must go speed later. That is slower than the low type. So they cannot cross more than once. Yes. And the single crossing is only needed. You want to have a separate equilibrium. If you don't have that, then the only equilibrium is cooler. Okay. So that is make the model more interesting. And later you will see why this is the case. If you don't have that, then you can easily check only pooling equilibrium exists. So now we understand this is the indifference curve and why these 2 points are the result of complete formation, right? But that is very simple, right? Because you know your thing, right? That is the maximum education you're going to do, right? Because you can do here many points, right? And you go up is better, okay? And your low type, your salary is here, right? You can choose whatever you like, okay? But this is the only thing you can get. And the highest point is this, only the tangency. Right? So this is the best education and best wage you can get, right? Because if you, of course, the low type can actually get here, but actually it is lower. Right? So that is only reason why the red dot is here. Same idea for this one. So these two represent the best education and the equilibrium wage when the firm can know whether you're high type or low type. Okay, if that's the case, you know perfectly. That's done, right? It's efficient. The model is over. There's no signaling. Right? So there's a benchmark model. Okay, is that clear? So you will see that with 2 cases here. One is called N.V. case. One is not N.V. case. Later you will see, but let me talk about this first. The N.V. case is no N.V. case is the low type and the high type. Okay. And look at remember this is the high type equilibrium wage. Okay. The low type actually don't envy the high type, which means that if you tell the low type, are you willing to go to graduate school? Then no. Okay. You're happy with the bachelor degree. No way. Okay. And the other case is what we call the envy case, which you will see the high type outcome is better. He want to pretend. Okay. And you can easily see, right? Low type want to be here if he can pretend to be there. Okay? Because this is in the higher set, right? For the low type. Okay. So you will easily imagine later we'll talk when he know every case, separate equilibrium is very easy. Right? Because the low type don't want to pretend, and high type of course don't want to pretend low type. So that means that separate equilibrium is very simple. But for this case, separate equilibrium can be difficult. Okay, so we have to figure out something else. Okay? But at the moment, let's look at the simplest model first. Is what we call the pooling equilibrium. Pooling equilibrium means in this context, no matter you're good or bad, you get the same education. Okay, the firm can't tell. Okay, and let's solve the model. Okay, if you can't tell, then by looking at the same education, your belief has no changes. It's still Q of the people is high type, 1 minus Q is low type because you have no information, right? You don't learn anything. This base rule require you that you see the equilibrium education level. That's what you believe. Okay, that's actually what happened in Taiwan since 2000. Everyone go to college. Okay? And if you go to college, degree basically is useless. You can't tell who is, right? Except in Taiwan, probably go to several top schools, otherwise you can say yourself, but otherwise you can't tell anything. Okay? Everyone got the same thing. Okay? Everyone got the same in the store. That means that you can't really tell, right? Or people call people in Harvard, right? Everyone got A. What's the point of this? The GPA has no meaning. Everyone got 4.0, right? So that's useless. Okay. So there can be many types of possible perfect Bayesian equilibrium you can imagine, because the off equilibrium belief, right? This is when everyone, and when you see the education according to this single level, you have Q here. Okay, that is following the Bayes rule. But when it's not, it doesn't matter what you think. Okay, so suppose everyone's supposed to get the college degree. What happens if you see a master degree? What happens if you see primary school degree? Okay, what happens to high school diploma? So there are many things you can do, but the one we focus on is we think someone do something other than what they're supposed to do. We believe that he is only a low type worker. Okay, if someone is outlier, we think he's crazy. Okay, he's a non-normal person. Okay, so this is arbitrary. Okay, and of course, in our model, we doesn't go detail more on that one. But anyway, if this is your belief, okay, this is free to set, but we just do a simplest case. Okay, if there's a case, the weight you got, okay, in the equilibrium has to be fixed by the perfect competition. So there's not too much choice here. Okay, so the wage is just the expected wages you got, right? So that's why the critical rational is simple here, right? Because the competition between firms. So there's not too much choice of the wage of the firm. So wage is just expected productivity here. If the market seeing that you are low type, no way you're high type, right? Then just give the low salary. If you're cute, possible high type, then just the salary according to this one. Okay. And the education you get must be actually equal to to this number, which is less than, or sorry, should be more than what the low type would do. Okay, this low type this is the minimum the low type would do, right? The low type would have this education, right? Cannot be lower than this low type, right? Because otherwise low type would do otherwise, right? Because it's optimality for the low type. Okay, because of the shape of the difference curve, right? Because you cannot be less than the E of the low type. So that means that this means you can't below this. You can't have below the E star L, right? So how do we make sure this exists? Okay, and this is very similar to if you learn concept theory. This is called incentive compatibility. Okay? Means that the low type don't want to do other things, and high type don't want to do other things as well. The first one is incentive compatibility for the low type. It's low type to follow the equilibrium. You get the salary, you get this cost of education that must be bigger than what they can do if they do the take the low type, right? Because the worst case scenario is the firm take the low type, which take the low type salary. Right? So that is this the case. Same the high type, right? The payoff of the high type cannot be lower than he pretend to be a low type. But do note that the last one is the cost is based on his high type plus lower. So that would be this idea here. Okay. What does that mean? It means the following. So this condition means the following. Okay. So here is the expected productivity. Okay. And the wage will be somewhere here. Okay. I don't know, but somewhere here. Okay. And this is the expected the pooling education. This is the pooling wages. Okay. So how can, and the belief is represented by the blue color. So if you see education other than EP, you get 0. If you think EP for the Q, that is high type. Okay. And this will support the wage here, right? And the wage you will give is this. If it is not EP, they will get low salary. Otherwise, you get this high. Okay. So now let's see if. So this is from the firm side. It's always optimal, right? Because the way we construct, okay, the firm is being the second mover. Right? The receiver is optimal to check. Right? Given the belief, we derive what they do. So the firm is optimal. So the only thing to check is same as we see whether the sender is optimal. And look at this case. The sender, the low type, the best case, he can go back, he can possible emergency, right? If you don't send this one, you just send this guy, this is the best thing you can do. See. And look at this in different stuff. You're here, but he's sitting here. So for him, he has no reason to complain. If they complain, then they go back here and to work on. So you don't want to reduce education. So it's okay for him. So that's why we compare this outcome with this outcome. Now, what about the high type? Can high type do anything different? The answer again is no. Why? High type, because facing this belief, what he can do is either take this salary or here, right? So remember the high type will be something like this as well. It's more flat, even more flatter, right? So, and that means that this is still above it, right? So it means that no way that he would take this rather than this guy, right? Or there's no point here rather than this guy, right? The only thing you can imagine is there's some point here, you can choose better this one. But because the way, the belief, okay, as long as there's no way that if things cross somewhere here, there's no tendency that is the best. That's the best. Okay. Is that okay? So that's pooling equilibrium. Is that okay? Why this equilibrium? Of course, you have to make sure that these two conditions are satisfied, right? But because in general, the y are not linear, right? So you have this thing is not something you have to calculate, right? Because the w depends on y, and the y can be any shape. I'm linear, right? But your y is some, I don't know what kind of shape you want. You have to make sure this is true. Okay? It's not guaranteed exists. Of course, if this is the assumption, the guarantee exists. Now the next thing is, I mentioned, the separate equilibrium of two types. One's no NV, one's NV. Right? No NV means that the low type don't want to mimic, as we have shown you, right? It's like what they're doing in optimal in the complete conversion case, okay, is don't want to pretend to be high type. Right? High type. So that means, as I said already in this slide, okay, even the low type are going to say, are you want to get education, right? Get high salary against no. Okay. And the other case is the low type want to pretend. Okay. By single crossing, right? You can see the high type don't want to move the low type. right? Because well, this is already done. Low type, the high type one. So the only thing you have to worry about is when separating equilibrium is whether the low type want to present high type, right? So high type don't want to present low type. So high type will not deviate, right? Because high type are paid by their expected salary already. Okay. Now, so let's look at the simple case. It's no NV. With no NV, it's very simple. They can separate. So high school diploma will get high school salary. College student will get a college salary, right? And the high school student don't want to go to college anyway, so that's fine. They don't want to deviate. So that's incentive compatible. So how can you do that? One way to do it, of course, there's many, but one to do this when you see people college above, then the high type. When they say high school, no college degree, then it's zero. Okay, very simple, very reasonable as well. And the salary offer will be according to this because for this case, firm don't have choice of wages anyway. So that's what you expect, right? You pay them the expected productivity. And the education they got is the low type get the high school and the high type get the college. Okay, very natural because that is very simple. The easiest case, right? Because you don't want to pretend. Okay. So this is the model. You will see the belief like this. Okay, is as long as it's not college, then you think they're low type. If you get college degree or higher, then you get high type. Okay, so that is very simple. So here, once you have this, then the red is immediate because that is you require, given your belief, that is how the firm give offer, right? If you believe that you are 100% high type, this is your offer salary. If you believe this is 100% you are low type, this is your salary. Okay, so that is directly. So this is the firm of the math is done, right? And the belief is done based on way. Right? Of course, you ask this belief doesn't really matter because you're free to take it. This is the never observing the equilibrium anyway. Right? So this you're free to do whatever this time. Okay, but just make it simple. Just make everything low. It's also very natural. Now to check whether the worker would send this message. Okay, if low type actually it's done, right? The low type wants to pretend high type by construction. There's no any case. And high type, as we said at the beginning, high type already also doing the best they can do. So in this model, actually good, everyone is very happy. There are no information loss, there's no gaming loss. Everyone's happy, right? Because low type would do even under complete information. Right? High type also do whatever they do under complete information. So this first test is right? There's no one actually getting more education than they should. Okay. So just imagine this case, right? In the marriage market, right? Poor people don't buy a house, right? Rich people buy a house, right? I think the house is who said no, right? And then no one is happy. You know, the poor people don't want to buy a house, right? The rent house, and rent house. So that's I'm happy yet. Although my wife is not, so that would be the answer. Okay? Everyone is very efficient here. Of course, this is less interesting. The more interesting case would be what we call the NV case. Okay? What can be done? Okay, there are many things you can imagine will be the low type, of course, can do the same as they do because they can always get the low types, right? The worst case scenario. The only thing here is the high type. What high type do? High type cannot because they envy, right? And the only thing they can separate from the low type is to go to school longer, right? And because of it's more costly for the low type to get schooling, in order to prevent them envy, you're getting more education. Okay? Separate them out. Okay, that's what happened, right? That's why people do pre-doc, people do postdoc, right? Stay longer in school, right? They eventually the low type. So that is how you do that, right? So that's why you the high type we have a ES, which better than the E star H. Okay. The reason is because the low type is when you're getting more costly for both of the people in the high type. Okay. Because you want separate ingredient. High type getting more education that they do. Right? So that's what happened in the marriage market as well, right? So in terms of selling gifts, right? If selling flower is costly, the rich guy will send really expensive flower, many gifts, right? You have so much gift that a low type cannot pretend to have that. So that's how they do, right? Or your time cost, right? If you really love that girl, then you keep writing letters, handwritten letters, right? The type, non-serious type don't have time, the playboy don't have time to deal with that. But if you're serious, you keep writing letters, then you can win the game. Right? So, and what is this? Is you just get education just that the low type don't want to be made, okay? Such that, yeah, the salary given to this is not the same as the payoff. Okay, you will see in the graph, simple. Later you will see the graph, okay? And here, the same before, you get this education high enough, you get high type, otherwise you get low type. And the wages are expected productivity. If you get high enough, it's a high type salary. If low, low type salary, okay? And education is star here as here. So the only difference is high type getting more education to not to being followed, okay? You get extra mile, okay? Like this. Okay. So how to read this graph? So first, we'll be looking at the belief first, okay? High type is here, and low type is doing there. The base rule will require this is 1, okay? And this guy is 0. And because other things can't observe, so we just extend 1 here, we just call it 1, 0 here. So base rule will require this report. Okay? But these are, I think it's very natural to think this. Okay, of course, you may see y has been 1 0, can be anything q here, that's okay. Okay? You can be just here just q, get this salary like this is also don't have to see all the way, but just to make the model very simple because it's all equilibrium anyway, right? You never observe this equilibrium. As long as no one deviates from it, you just focus on this simple case. Okay. And once you have this belief, and the salary must be following this line because that's not because two firms are competing. So the wage is not a variable, just have to be same as the expected productivity, which is here and here. So firm is done. Now what we observe is whether the worker will do the way we want. Okay. First, look at low type. This indifference curve here, right? Will the low type do things that want to mimic the high type? Okay. But remember how the construction is we draw the indifference curve all the way up to here, okay, and cut this productivity, okay, which means that this is the point that low type indifference between mimicking. Okay? So that means that you do not need. Well, you can measure the slightly more, so it's certainly not to mimic, but we just make it simple, right? It's indifferent. So here you don't want to change anyway. Okay. Okay. And remember the single crossing property. So if the low type don't want to mimic, the high type don't want to go down, right? So the high type is very happy as well. Okay. So in this point, okay, there are some wasteful spending, right? Because in order for the high type to defend the low type, actually high type doing some what we call over-investment, right? They over-invest in their education. That's why now in China, everyone is doing the PhD degree, right? What a waste of resources, but because of the too many people, you want to signal, you want to differentiate from normal undergraduate, you need to do it, right? Because otherwise you get a low salary, right? So everyone wants to do PhD, right? It's not PhD may be very meaningful to do it, compare cost and benefit, right? If there's no information problem, probably don't want to do it. But because of you don't want the low type to pretend like you, so you go for a PhD degree, right? You go to a master degree, right? So that's why everyone go to overseas to study the master, right? PhD, right? Or do a lot of things, right? And not because of you need to, but just get it to show for you to mimic. Right? That's why you see people winning at the starting point, right? Why the primary school student have to instead more than study, they learn piano, running, singing, music, a lot of drawing, a lot of basic things, right? Which is usually have no point of doing it. You do it because you look on defensive, right? Don't want to be the same as the other guy, right? It's not ordinary to show you, and it's cost to do so, right? And because of if you're smart, you can do those nonsense easily, right? So defensive matters, not because of this efficient to do, but so in this NV case, basically just like the society encourage the cost of this, right? To separate them. So that is the idea. Is that okay? Is that okay? So it's not that easy to understand the graph, but hopefully I think I draw in the way that you can see instead of this efficient one, you have to everyone got higher salary, but also higher education. But this increase in salary is not enough to compensate, right? If the low type labor gone out of the market, they will not have this problem. Okay. Now, from this, we actually know how to derive this, right? And we see there's a cooling equilibrium and separating equilibrium. And that's done for the perfect phase and equilibrium. So now here comes a much more complicated thing. Okay. It's more difficult, but I think from now on it's becoming more complicated. Okay. The reason is there are many equilibria, then what should be the main thing, right? There will be cooling separated. To what extent? So we need to do things more. Okay. What we call refinement. Okay. And you will see when we derive this, okay, there are a lot of freedom on the belief. Okay. Besides this point and this point, other things are free. Okay. And the free belief actually has a problem. You won't believe that is the case. Okay. And there are many things you can think. Okay. So we will consider what we call two refinements of the belief. Okay. The first one is called dominated belief. The second one is a very famous one called intuitive contribution. Okay. And you often learn it again. It's often they will have these two, so I have to cover that. The first one is called dominated after this after the break. So we'll talk about the example later, but let me finish this one quickly. So dominated means that if a type, okay, T, okay, is dominated to send this message M, okay, if, okay, this type, okay, according to this type T is dominated, okay, which means that sending this M message, okay, the best case scenario is worse than send another message. The worst case scenario is the best. You send another this message, okay? But if you send another message, the worst case scenario, okay, is better, then this got dominated. Okay? We'll more clearly. So that is more like, it's very similar to the solely dominant as well. Okay, but it's not exactly. But this means there is a strategy, okay, that will guarantee you the worst case scenario better than the best case scenario. That means that you would never believe that this dominant type would send this message. When you see this message, you cannot assume that this is type one. So that means the idea is similar, like if you see a huge amount of education, it's way more than normal, then you can't really believe this type, right? You can't, the super, no matter what you do, right? You're overeducated, right? You want them to do what you're doing right now, right? So that would be very clear after the break, okay? But the idea is, if some message, okay, is too stupid to be sent, okay, which means that in the best case scenario, cannot better than that, okay? Because it's taking the maximum A can do, the minimum A can, right? Then you would be there, right? Suppose, right? If education for low type, the cost is more than the possible wages you can take, right? Then you will not be useful, right? Suppose it this way, right? Suppose the high salary you can get, right, is like, say, suppose $1 million, right? And if you get education, the cost is like $2 million, right? No one would believe this standard by the low type, right? Because low type rather stay home, not do anything. There's no way that you would believe that the low type would actually go that route. Later you will see what kind of equilibrium EQ after break, and you will see this would it will kill the pool will kill the pooling equilibrium. Okay, the pooling will have will kill some separate equilibrium and kill some pooling equilibrium. Okay, but that's we'll talk about that after the break. Okay, let's have the break. Of 10 minutes, I guess it's okay. So I go around to celebrate. It's almost done there. Or something. Celebrate again because the last thing we celebrate. I don't think you can put the celebrate in the next one. Even if you can celebrate. Yeah. You only have several slides left, so we're done. Anything to talk about? Yeah. Celebrate. So maybe let me continue. So the idea of this refinement is saying that if some message, if sending out would only lead to worse outcome than the worst case, okay, even the best possible, then you would never expect assign this even off equilibrium. Okay, so there's a refinement of equilibrium. So what does that mean? Okay, so it means, let's say the following. So you will prove, we argue this is the case. It is dominated, okay, for high type to send more than ES, was ES. ES is, you remember, ES is this guy. Okay. Yeah, ES is the guy we just saw, the separating equilibrium. Okay. So what does that mean? Let's see the picture. I guess that would be easier to see. Okay. So would the worker able to send more than the thing that the high type would do, right? The ES is the high type. Right? So look at the proof, right? But going to the math, you would say, okay, sending more will get you negative. Okay. Okay. Look at this. Look at this question. Okay. So we argue that this is only possible. Okay. Why? Why this is, so suppose this case compared to, okay, we already know there's no problem for this one, right? I mean, but here we are saying that, okay, the worker, okay, would they believe that he is going to send here? Okay, so the question is, okay, so look at this. Why I remove the E star more than ES is gone. Okay, and we have ES is here rather than the previous case. Okay, check here. Okay, so would you see this case? So what you expect, right? So you so why only this thing would happen? Okay, why you would believe this is low type, and why this you have to, why this will you can go down? Okay, why you believe this high type? Okay, and why you still think this low type? Okay, you have to put 0 here. Why? Because would, if the low type, here we believe that if you have this education, you are low type. Okay, but we argue that it's not possible. What's the case? So you send it here, right? the best thing you can do, you can imagine is what? If you low type, get this thing, right? The best thing you can imagine is your heat, right? Is the high type productivity. Right? So the best case scenario is here, right? So you can imagine the word with the low type, you get this one, right? And because the NV, right? So you would you can still, this is not dominated. Okay. But what about this one? Okay. This one I said is free. Okay. But this one must be flat. Okay. The reason why this one must be flat is because you will, a low type, you will never go to more dissatisfaction. Right? By going more, actually your utility is below this point. Right? So rather you go back to here. Okay. Because the worst case scenario is that. Right? So that means that it must be 1. So this dominant belief, you make sure that this must be 1. Okay. But you can't say anything here now. So that's why what we do is just to kill all the equilibrium, okay, such that you require them to do more than this. Okay, because although I show you the best case scenario, okay, you can imagine your equilibrium separating is can be up to here and go to here. It's also possible. Okay, because in this case, high type will not deviate, low type will not deviate. Or this is the best case scenario. But basically, this type equilibrium is few because it cannot be zero. So this type equilibrium is few. So what is left is this type of equilibrium. What is this type of equilibrium? If you just draw a picture that this also is separate equilibrium, but it will violate the CO dominated group because and for this one, it's a separate equilibrium, right? And low type don't want to mimic high type, right? And high type don't want to mimic low type, right? But in this case, high type is getting way even more agitation. Okay. But this will not be the case because getting this agitation is dominated for the low type. The low type will say, okay, I want to do that. I will just do this. Right? In that case, right? Offers off equilibrium, but it can't be true. Okay? So that's why we only left with this type of equilibrium we have seen already. Okay. What about what is killed as well is some separate equilibrium. Okay, some full equilibrium as well. Okay. So we'll argue that, okay, this is our ES, right? EH cannot be more than ES, so this is the case. And we say that, okay, beyond ES, it must be 1, right? So that's what we said, right? Because dominator means that more than this cutoff must be already 1, right? That's what the dominator said, right? If it is too high agitation, okay, the low type will not get it, rather you go to low. So it must be 1. So basically you are saying that the zero domination is require you to have this one. So that's the only thing we get here. Okay. But this one can kill full equilibrium. Why? Because pulling them like this, right? This is the pulling equilibrium, right? But given this, you are going here to here, right? Because your high tide here, so you pay this. And look at your high tide, the indifference curve is here. And accordingly, if you are, this is the pulling, your status here. Right? So as long as your Q is low, so this line is low, if more will be close to the bottom, right? Rather than to the top. Right? Because the bottom, this indifference curve will be higher than this guy. So this when Q is 0, the pulling will not exist. Let me repeat the same way. Okay. For low Q, this line is very close to the low tide. Okay, rather than high tide. Okay. That means that the pulling wedges is very low. Okay. And but because of the C dominant means that when you have very high allocation, then the low tide will want to. So we are paying this one. Okay. And this kind of salary, look at this high tide, can be higher than this one. Okay. So there's no pulling, no matter which one you pay, can achieve as good as one. So high tide always can be separated. So that's what you do, right? So because of the low tide cannot get so high allocation, that means that high tide able to distinguish himself in very high allocation. Okay. If the pulling wages is not that high enough, then the super education can kill it. Okay. Although this is not optimal for high tide in the company case, right? The best case, of course, high tide would actually somewhere here, right? In difference before, but so that's why this is being Q, right? But of course, if you have high Q, you still have that, right? Because the high tide indifference curve, this one still pass through here. And this point is still better than separate, right? Super education is not better than the mixed with the low tide, right? Because education can be very costly, right? And this, okay. So what we left is some separate equilibrium and some type of pulling equilibrium. Okay. So this is the just by removing that, the high tide will not get super education. Okay. So that is our assumption, right? It's just like, okay, will not get more education, right? Because he can always get the lower salary if possible, right? The lower salary, even high school diploma can get that salary, right? You will not spend too much resources to get a doctor. Right? If the return from doctor, even they think you're a doctor, you higher ability, right? It's not worth it. Okay? So that is high. So we have that cooling equilibrium. Is that okay? If not, let me repeat it because it's very important to make it understand. So here is that if a type he sends this message, the best case scenario is no better than worst case scenario, then no one will believe this type will be belong to this message, right? So here, what it means is look at this case, look at this point, ES is here, right? So it must be the case that beyond ES, it must be high tide, right? Because the getting more than that is below the difference. Okay. So basically this requires the blue line. So that is what the criteria do. Okay. So that means that you kill any equilibrium that doesn't satisfy this one. Okay. For example, I told you, you can require low tide here, right? And actually high tide on here, but beyond here, that's okay, right? It doesn't vary anymore. Okay, because the firm may just ask you to have a lot of education, right? Otherwise consider low tide. That's okay. The high tide cannot be low tide anymore. But this is not possible. The firm cannot require to get huge amount of education. But otherwise, This low type actually goes at high type. It's okay. I get a little bit lower, right? What you think high type, right? Because I will tell you that low type is not to do it, right? Basically, just telling you that, okay, I get this education. I'll tell the high type, see, I cannot be low type. Right? If I'm low type, I'd rather get a high school diploma. I get my doctoral degree because I'm doing it. Okay? So I have this education, you should believe they are high type. Because if I'm not here, if I'm low type, I actually will not get this education. I will just get this one. I'm very happy. So you should believe me, high type, give me 5%. That's the idea. Right? Because there's no way the low type can be me, right? The low type would be me, then he would just actually get it. You're going to convince you get the off equilibrium. Okay? That's how you kill this, right? Because you only observe this dog, right? You never observe something that's not in equilibrium. But you're trying to convince the guy that that's the case. Now we come to the very last thing. Okay, I think it's the most complicated one in our course, which is called implicit criteria. But I would say again, its name is not intuitive at all. You understand it's very intuitive, but you never understand that it's very, very complicated. Okay. So it's intuitive in the following way. Okay. You said that a type is equilibrium dominated. So we're saying that's the case. Before the right hand side saying, you send this type, you send the best possible scenario. Right? Let's say you send this possible scenario is less than the equilibrium you can get. So it's weaker, right? Before the left hand side, the minimum, right? The worst case scenario. Right? There's a worst case message that you can send. Right? Still better than the best case scenario. Okay? But now it's weaker. I'm not requiring the minimum. Just to compare this one. Equilibrium dominant is replace this guy with the minimum, right? Before it's minimum. Now it's just like we less this because we need to strengthen it to kill more equilibrium. So that's why we need to allow the domination to be weaker. Right? We allow the equilibrium. Okay, this doesn't make sense for you, right? Rather than the best case scenario. Okay, and that means that if some message is equilibrium dominated, you will see. Okay? So that is a little bit convoluted. You never understand by definition. Let's look at the graph, then you will see. Okay. So let me look at this graph, the very last graph, and we go slowly on this one. Make sure everyone get this one. You can tell me whether it's intuitive or not. Okay. So first we have EP is our polar equilibrium, right? Remember, we have already killed the low Q, right? Only have the high Q thing. So in the equilibrium, we require that, okay, the EP, then you give the salary, right? The salary is the expected productivity, right? So everyone in the equilibrium will propose is everyone get this education EP, okay? And the firm will believe that Q of time, your high type, minus Q of low type. So this is your salary, right? And equilibrium would require in general, right? Here is more than ES must be 1. This is coming from what we have previous refinement, right? That is the equilibrium dominated, right? Because beyond ES, no high, no low type to do it. Right? So this blue line is coming from this blue line coming from the domination, right? Our previous case, okay? And then we require, okay? Other case can be anything, right? Because you don't observe this, is the only thing you observe, right? And this is coming from the criteria, okay? Dot equilibrium dominated. Okay. And then you probably want no deviation, right? So you really want the other thing to be simple. Everything's below type, right? That is the standard thing to do, right? To make life easier, right? You see, then what you see is low type. Right? But now you take low type, then you pay low type standard. Okay. But we are saying what we call equilibrium dominated means if you see something between E prime and E double prime, there must be high type. Okay. But let me argue why is the case. What is E prime here first? E prime here is look at the low type here, okay, and you draw the difference curve up to this high volatility. This is that. And what is E double prime is the same, but it's a high time. Okay. So you draw a line there, and intercept is called E double prime. Is that clear what's E prime double prime first? Right? E prime is from the equilibrium indifference curve. So the low type is indifferent between this, okay, and if you pretend to be high type, right? Here the high type if you is indifferent between getting the pulling result or if he get the high type salary. Okay. So we try to argue that okay, low type would not want to be here. Okay. Why? Okay. Look at low type. Okay. This outcome are worse than this. Look at the equation. Okay. Remember the definition. What is so? If you get this education, the low type, the best case scenario you should get the high type salary. Right? It's the best possible. Right? So that is the right hand side variable. Right? The right hand side is this is this one, right? This is the right hand side, the best case scenario, right? You send this message for the best possible salary. Okay, you get this salary. Okay, but this is worse than what you can get in the beginning. Okay, so this is equilibrium dominated because suppose you are in this equilibrium, right? Put equilibrium. Right? Then someone come in with this education level. They will tell you that, believe me, I'm a high type, must be, right? Because if I'm not, I'm no type, then what I'm doing, because in equilibrium, look at this one, right? I come to here, there's no way I'm no type, because otherwise I would be going back, right? So that's why you must believe I'm one, right? So that is the requirement. Okay? But if that is the case, high type would take this one, would kill this equilibrium. Why? Because high type is happy here. So you equilibrium see all this here. So high type give you. So that's high. So let me do it again because this is not intuitive. Although it's not intuitive criteria. Okay. So first, look at this problem again. Okay. So this low type is the worst case scenario, right? It's a pulling equilibrium. Okay. And what is the belief here? Base rule requires Q. No doubt. Right? This only thing from the perfect base equilibrium. Okay. And this only thing they put here, there's only thing you then you're done satisfied. As long as you put all the thing low, then no one deviate. Right? So that's the easiest thing. Now, if you have domination, okay, like limits of domination, you have this line. Why? Because low type, okay, the best is this one, right? Even if they get super educated, they get this salary, they're not very happy. Actually, they would actually go back to high school, right? Don't want to do the PhD. Right? Beyond the PhD, student postdoc for the low type is not going to work, right? So that means that this one is mine. Okay, that's done. now we have interior criteria. It's a similar idea. But instead of comparing the best case and worst case scenario, compare equilibrium scenario. Okay. In equilibrium, there here. Okay. And look at here, if you are high or low type, getting this education, getting the best case scenario, okay, it's not better than what you have here. Right? Even if you are low type, you are getting more education, you get mistreated, okay? You get really lucky, you think you're high type, you actually want to go more into it. You don't want to pretend, right? There's no way you will mimic getting this, okay? That would be if equilibrium's here, okay? There's no low type will come to here. There's no reason. Right? No reason. That means that it must be high type, right? Because in the best case, it's not here. Okay? But if the firm believes these are high type, okay, and to get the high type salary, right? And that means that the high type will deviate because high type look at things in different terms. You will be happy here. Okay. So that's the reason why we have this integral criteria. Is that clear? So as usual, when we have this complicated like equilibrium dominated into criteria, I did it last year, I didn't. It's not included exam. So the exam will be if we ever ask the baseline game, it will be up to this slide. Okay, it will be up to the 38th slide. So this refinement of equilibrium and the integral criteria is too complicated to put into your exam. Okay. But that is something that you will see all the time in the criteria. It's saying that the idea is like in the equilibrium, they're all pulling, right? So the high type will say, I get slightly more education, which low type don't want to limit, okay? And that the firm would able to believe them. Of course, it's a strong concept, it's comparing equilibrium idea. It's much stronger than the previous case. But that is called the integral criteria. Okay. So I know this last two is very complicated, but don't worry, you never use it unless you work on second game. Okay. For me, I will never need it unless you really work on this. But you need to know this because whenever people talk on game, they will talk on integral criteria. There are too many equilibrium, so that's why you have to have your apply integral criteria. To come to the seminar last time, we actually talk about integral criteria. There will be focus on some equilibrium. So for last 1 minute in this class, I have no minute left, but just still 1 minute from you. We are actually from this course, just to summarize a little bit quickly, maybe give you 1 or 2 minutes. So we actually cover 8 main topics. The first 4 topics will be standard microeconomics. Okay, look at market, look at consumer, look at producer, how to derive market demand, individual demand, market demand, how to derive supply function, right? And how to look at the market, look at general equilibrium, how to solve various equilibrium for one corner. And after that, we focus on game theory, right? And game theory, we look at 4 different kind of games, right? Perfect information, static game, dynamic, and also there's a combination 2x2 is a 4, right? So basically, you are equipped with all the tools that actually write basic business model. Okay. You don't really go beyond, and as we talked during the break, I mean, now these days, a lot of papers that require inside regression with a toy model. And our class, I think, is enough for the toy model. Either you use perfect combination or you use the game theory. Because you really need to, when you run regression, you have many hypotheses, you really want one framework to contain everything. That is what is to understand. Okay. So the remaining time we do CTE. So I will be excused. So I will see you next week.